Welcome to my project bazaar.com.
Now we discuss about the mixed noise removal by weighted encoding with sparse non-local regularization. In this process, we remove the mixed noises. The mixed noise will be the adaptive wood Gaussian noise and impulse noise. The impulse noise will be the salt and pepper noise and also the random variable impulse noise. The adaptive white Gaussian noise is the white noise and also the impulse noise will be the color noise. The white noise is the unwanted pixel with a range of minus infinity to plus infinity. The color noise will be the 0 or 255 range which is randomly ordered in between of our original image. This noise will be removed by using the weighted encoding space non-local regularization. In this method, we use the BCA dictionary for reference of remove the noises in our input image. We add the different type of noise and also remove the different types of noise, and we calculated the BSNR value for each noise. In this process, we use the iteration level for remove the better noise removal. And then here the weighted encoding method, the weighted will be the BCA dictionary values, and then it is encoded and then it is compared to the BCA dictionary. The BCA dictionary will be extracted from the 5 better quality image. That quality image feature will be compared to the noisy image to remove the noises in our process. After the noise removal, the BCA dictionary will be help to restore the image with specific level. Now we go to explain of our flow diagram. It is the flow diagram for our proposed system. In this flow diagram, first we give the input image and then we add the different types of noise like a wood Gaussian noise and the salt and pepper noise or the random variable noise. Then we use the median filter for initialized image. Here it will be used to reduce the noise level with high accuracy levels. After the median filter, then the input image will be go to the WSNR algorithm. In the WSNR, the initial image and also the noisy image will compare to and then find out the residual value. And using the residual value and compute the coding vector. The coding vector will be the BCA value. After the BCA will be reduced and then that coding vector will be compared to the BCA dictionary. Then it will be remove the noises. And then here we give the iteration level. And then we take assume the iteration is the I and then the updated iteration will be UI. Then the updated iteration will be equal to the iteration. Then the process will be stopped and it is the final noise removal image. Or else we go to the another type of another process like computer coding vector. After first iteration, the computer residual will be calculated based on the initial image. After the iteration will be updated, the initial images will be changed. Like the initial image will be the previous noise removal image of WSNR, and then each iteration it calculated the residual value and weighted value, and it is helped to improve the noise improval level at very well accuracy. Then we go to demo of our process. Now we going to demo of our process. Open the MATLAB source code and then right click the main.m and then run the file. After running, the dialog box will be open for add the noises from the input image. Here it is the our input image process. First browse the input image and then choose the image folder and then choose any image from here. Then click open. Here it is the input original image will be shown. It is the input original image. Then we add the noise. First I add the white Gaussian noise at the 19% and then we add the spin noise with the 13% and also the RVN noise with 11%. Then we go to the noise removal process. Then it is the process of noise removal. Now we give the sigma value for noise removal and then give the iteration for remove the noise in better level. It is the DSNR value of noisy image which compared to the original input image, and then we find the BCA dictionary for reference. It is the BCA dictionary value. This BCA dictionary value, it is the centroid value. The BCA dictionary will be extracted based on the centroid value. This BCA dictionary will be extracted based on the k-mean clustering. After the BCA dictionary extracted, then we initial the image by removing the impulse noise by the random removed noise. Then it is the pre-noise removal image. Here the random noise will be removed and the white Gaussian noise will be added. It is the initial image. Then we go to the RWN for remove the mixed noise with the WE SNR algorithm. Now we take several iterations and some time for process. The first iteration will be done, and then the DSNR will be shown. And after the second iteration, the DSNR will be updated. The graph will be show the updation value of updation DSNR of each iteration. So the iteration will be run, and then our DSNR will be increasing at 24 to 29, and it is the MSC value of iteration 3. And it is the final result. It is the initial DSNR and it is the initial MSC value, and it is the initial FSIM, and it is the final DSNR and the final MSC and the final MSC. See this result, the initial DSNR will be 14.2. The BSNR will be definitely increases. So the final BSNR will be improved at the 50% of initial BSNR. After the initial MSC value will be here. The BSNR and MSC will be inversely proportional. So the BSNR value will be improved, the MSC value will be reduced. Here also the MSC will be reduced at very well level. And the FSCM is the feature similarity index. Here the image will be checking based on the feature level. So it is also improved at like a BSNR. So here the initial FSCM will be 72%, and also the final FSCM will be the 93%. And here so the visually reference for our noisy image and the noise removal image, and also here shows the BSNR value of the initial process and also the final process. It is the FSCM graph for FSCM graph for our WSNR with each iteration. In this graph shows our FSCM will be improved at the second iteration. So that reason in that type of image we add the noise like the in between the 50%, then we use 2 iterations for get the better result. After else it will be over something, and then the PSNR value and FSCM will be reduced, so the quality will be changing. That graph will be shown this type of value, and also the MSC value will be the second iteration is the best, and also it will be increased. Then also the BSNR will be same. Here the second iteration it is give the better BSNR value. After the second iteration the BSNR value will be reduced. Thank you.